The Boolean data type, often shortened to bool, is a fundamental concept used to represent two possible values, true and false. It represents the basic concept of truth values, similar to a light switch that can be either on, true, or off, false. True means something is correct, or it happens. False means something is incorrect, or it does not happen. Boolean values are essential in programming because they allow us to make decisions and control the flow of our programs based on certain conditions being met or not met. They are often used in conditional statements, loops, and logical operations. In Python, the Boolean values are represented by the keywords true and false, which are reserved keywords and must be capitalized exactly as shown. These keywords are built-in constants in Python and cannot be reassigned to other values. We can directly assign true or false to variables. Here's a simple example showing how to use true or false values in Python. Is daytime equals true? Is logged in equals false? Then, print is daytime. Print is logged in. We press the Run button to start the code. In this sample code, we assign the Boolean value true to the variable is daytime, and the Boolean value false to the variable is logged in. In addition to the arithmetic operators we have seen so far, Python also provides operators that work specifically with the Boolean data type, those trusty true and false values. These operators are categorized into two general categories: logical operators and comparison operators. Their combination is often used for making decisions and controlling the flow of a program based on different conditions. As we continue, we'll take a closer look at both types of operators. Python provides three logical operators that operate on Boolean values, and, or, not. These operators are used to combine or manipulate Boolean values and create compound conditions. They take Boolean operands and combine them according to specific rules, always resulting in another Boolean value, true or false, as the output. Let's explore each of these operators in detail. The AND operator returns true if both operands are true, otherwise it returns false. For example, x equals true, y equals false. Print x and y. This code shows how the AND operator works. It assigns true and false to variables, uses an operator to see if both are true. Because an operator only gives true when both variables are true, the result is false because one variable is false. The OR operator returns true if at least one of the operands is true, otherwise it returns false. For instance, x equals true, y equals false. Print x or y. This code demonstrates the OR operator. It assigns true to x and false to y. The OR operator checks if at least one of the variables is true. In this case, since x is already true, the result is always true, no matter what y's value is, because OR just needs one true value. The NOT operator returns the opposite Boolean value of the operand. If the operand is true, NOT operator returns false, and if the operand is false, NOT operator returns true. Here's an example. X equals true. Print NOT x. This code showcases the NOT operator, which flips the truth value of a variable. It assigns true to x. Then, the NOT operator is applied to x. The NOT operator essentially inverts the truth value, so not true becomes false. We can combine logical operators to form more complex Boolean expressions. Python follows precedence rules when evaluating expressions, with not having the highest precedence, followed by and then, or. However, we can use parentheses to override precedence and explicitly specify the order of operations. Consider the following example. X equals true, Y equals false, Z equals false. First, it assigns the values true, false, and false to the variables x, y, and z respectively. Then, in the next line, result equals parentheses x or y and parentheses not z. Print result. After running this code, the expression x or y evaluates to true because at least one of x or y is true. The expression not z also evaluates to true because z is false, and not false is true. Finally, true and true are combined with the AND operator, resulting in true. Comparison operators, also known as relational operators, are used to compare two different types of values such as numbers or strings and return a Boolean value, true or false, based on the comparison. These operators help us make choices and control how our programs run. We can use them in conditional statements like if to execute specific blocks of code based on the comparison results. This table shows the 6 main comparison operators for Booleans. We'll look at each one with an example. Equal to. This is shown by using the double equals operator. It returns true if the operands on both sides are equal. For instance, x equals 5, y equals 5. Print x equal to y. This code snippet assigns the value 5 to both variables x and y. Then it checks if x is equal to y using the comparison operator double equals. Finally, it prints the result of this comparison, which will be true since x and y both hold the value 5. Not equal to. This is shown by using the exclamation mark and equal sign operator. It returns true if the operands on both sides are not equal. As an illustration, x equals 5, y equals 8. Print x not equal to y. This code assigns the value 5 to the variable x and 8 to the variable y. Then, it checks if x is not equal to y using the exclamation mark and equal sign operator. Finally, it prints the result of this comparison, which will be true since 5 is not equal to 8. Greater than. This is shown by using the greater than symbol operator. It returns true if the operand on the left is greater than the operand on the right. For example, x equals 10, y equals 5. Print x greater than y. This example compares if 10 is greater than 5 and prints the result, which is true. Less than. This is shown by using the less than symbol operator. It returns true if the operand on the left is less than the operand on the right. For instance, x equals 3, y equals 7. Print x less than y. This code sets x to 3 and y to 7. Then, it checks if x is less than y and prints the result, which is true. Greater than or equal to. This is shown by using the greater than or equal to symbol operator. It returns true if the operand on the left is greater than or equal to the operand on the right. To illustrate, x equals 10, y equals 10. Print x greater than or equal to y. This code assigns 10 to both x and y. Then, it checks if x is greater than or equal to y, which is true, and prints the result. Less than or equal to. This is shown by using the less than or equal to symbol operator. It returns true if the operand on the left is less than or equal to the operand on the right. For example, x equals 5, y equals 10. Print x less than or equal to y. This Python code assigns 5 to x and 10 to y. Then, it checks if x is less than or equal to y, which is true, and prints the result. Difference between assignment and equality operator. In Python, the assignment operator and the equality operator serve different purposes, although their symbols might appear similar. Understanding the difference between these two operators is important for writing accurate and clear code. Assignment in Python is denoted by the equal sign. It creates a new variable or updates the value of an existing variable. The value on the right-hand side of the assignment operator is evaluated, and the result is stored in the variable on the left-hand side. Equality in Python is a comparison operation used to determine if two values are equal. It is denoted by a double equal sign. It returns a Boolean value, true or false, indicating whether the values on either side of the operator are equal or not. The equality operator does not modify the values being compared. It simply checks if they are equal. This example shows how these two operators work differently. X equals 5, Y equals 5. Print X, double equal sign, Y. Let's execute the code. In this case, both X and Y are assigned the value 5. The equality comparison evaluates to true because both X and Y hold the same value. Remember, the assignment operator and the equality operator cannot be swapped. Attempting to use the equality operator for assignment will result in a syntax error. Likewise, using the assignment operator in a conditional statement or comparison might cause unexpected results. The comparison operators can be used with various data types, such as integers, floats, strings, and other comparable objects. For example, strings are compared based on their character values and positions. Print apple is equal to apple checks if the two strings apple are identical. Since they are the same, the result will be true. Print banana greater than apple compares the strings banana and apple. In Python, strings can be compared alphabetically. Because banana comes after apple alphabetically, the result will be true. It's important to note that Booleans are considered a numeric type in Python, meaning that they can be treated as numbers in most contexts. This means that we can perform arithmetic operations on Booleans and compare them to numbers as well. Take a look at these examples. Print true is equal to 1. Print false is equal to 0. Print true plus 4. In the first two lines, the code checks if true is equal to 1 and false is equal to 0. Although these might seem like unexpected comparisons at first glance, Python evaluates to true in both cases. This is because behind the scenes, Python assigns a numerical value, 1 for true and 0 for false, to these Booleans. So, these lines are essentially comparing 1 to 1 and 0 to 0, which are indeed true statements. Lastly, the third line performs an arithmetic operation where true is treated as 1, and 4 is added to it, resulting in 5. While it works, relying on this behavior can be confusing and is generally not recommended. For better readability, it's best to use Booleans for logical comparisons and numbers for math operations. Comparison operators are often used in combination with logical operators to create more complex Boolean expressions. They help the program make decisions based on multiple conditions being true or false. Let's see an example of this. Think about these three variables. Age equals 30. Is student equals false. Has experience equals true. Next, we'll use these variables and mix logical and comparison operators to see how it works. Is eligible equals age greater than or equal to 25, and not is student or has experience. And then print is eligible. Time to execute the code. In this example, we check if age is greater than or equal to 25. We evaluate not is student or has experience to determine if the person is either not a student or has experience. Finally, we combine these conditions using the AND operator to get the overall result. The result will be true because all the conditions are met. Let's look at another example that combines comparison operators in a slightly different way. Age equals 40. Minimum age equals 17. Maximum age equals 66. Valid age equals minimum age less than age less than maximum age. Print valid age. Age holds the value we want to check. The other two variables, minimum age and maximum age, define the lower and upper bounds of the permissible age range. Python allows chaining of comparison operators, a technique known as comparison chaining. Through the expression minimum age less than maximum age, Python simultaneously evaluates if the age falls within the designated range. The logical combination of comparison operators effectively ensures that the age is greater than the minimum age requirement and less than the maximum age threshold. Python actually handles this expression like this: minimum age less than age less than maximum age, in the logical and operation between the two comparisons. But if we need to compare within a specific range, it's recommended to use the chain comparison technique. Pycharm also encourages us to simplify the code using this technique. To do this, just click on the Simplify Chain Comparison option to change the code back to how it was before. By assigning values 17, 40, and 66 to minimum age, and maximum age respectively, the expression evaluates to true, since 40 falls between 17 and 66. This concise approach eliminates the need for separate comparisons using logical operators and demonstrates the power of combining these operators to create more intricate conditional statements in Python code.